This is the On Humans podcast, a show which makes new research about humanity more accessible to everyone and more meaningful to the big questions about who we are. I'm your host, Ilari Mäkelä, and today we continue the mini-series of live episodes in which my guests do their best to use genetics to decode the human story. All of these conversations were recorded at the Carter Symposium on Human Origins held at the Salk Institute. More on that in the show notes if you want to check it out. Now, today's episode is a delightful conversation about a troubling topic: race. Now, you have probably heard that modern genetics isn't exactly the best friend of the idea of splitting humanity into 5 or 6 distinct races. Indeed, one of the organizers at the symposium told me that when asked to tick a box of his race, he has long ago stopped ticking Asian or Asian Indian. He ticks other, human. But if you follow this topic, you likely have seen also a kind of glass half full, half empty way of thinking about this. According to this view, yes, the old ideas about races were not quite right in the way that they tried to cut the cake, but still there are real differences between populations. These are the differences that genetics studies, so sorry guys, get used to it. Now, I think that that's a misleading picture. I'd rather say it this way. The glass is mostly empty, and the liquid in it isn't even what the race theorists believed. Now, the first reason is that these differences, even when they are there, they're not very clearly mapped onto anyone's face. So this is not race 2.0, because you cannot get to the inside just looking at the outside. But even when you do get to the inside, I think it's easy to lose sight of the all-important question of, well, how big or small are these differences? To answer that question, here is Diyendo Massilani, who runs a lab at Yale Medical School, and whose lab has produced a really wonderful analysis of this question, which, by the way, is not out in the papers yet, so this one is very much a peek behind the curtains. So here is Diyendo Massilani in actually the shortest episode in the history of On Humans, but one which packs so much material into these 15 minutes, so I hope that you enjoy this. Let's go. Professor Diyendo Massilani, welcome to On Humans.
Thank you very much for having me.
I think a lot of people will have heard the term out of Africa as a model of human evolution. What does it mean?
The term of out of Africa is that idea that modern human emerged in Africa, and at some point in time, a subset, like a population of those modern human in Africa, migrated out of Africa to colonize the rest of the world.
And was it one population who left, or were there many out of Africa during that time?
So it looks like we have more evidence that there were more and more out of Africa migration, but those earlier modern human getting out of Africa did not contribute ancestry to the people that are here today.
They were dead ends.
They were dead ends, exactly. They went extinct. And essentially that one population that probably went out of, like, that at some point was out of Africa at some point, and that contributes like to all present day that we are seeing today, from like Europeans to Oceanians to Native Americans.
And so if we think of a branching of the human family tree, this would be probably a major branch would be one that leaves Africa. But of course, a big branch stays in Africa.
Exactly. So the story of modern human actually started like 300,000 years ago with some divergence. And the subset of people that went out of Africa actually diverged from another population in Africa less than 100,000 years ago. So you have like a first earlier divergence in Africa. And that's why today, when you compare the genetic differentiation between, for example, like if you take like a group of like Bantu in one location, for example, Central Africa, and the hunter-gatherer pygmies that live like a kilometer away, they are more divergent than when you take like a European and a Chinese person.
Wow.
Even though they live at 1 kilometer away, because like their story of divergence is much deeper. And you have to see like, especially that population going out of Africa around like probably like 50,000 years ago, diverged only at that period of time to create like what is now like the Western Eurasian, like the Europeans, or the Eastern Eurasian, the Asians, when the population that stay in Africa diverged like 300,000 years ago. So a bigger time of divergence, so much more diversity and much differentiation between the population living in Africa than the population that went out of Africa.
So the human family tree, the first major branching is not when there is the out of Africa event. The major branches are happening within some African populations. And then one of these branches becomes the out of Africa branch, out of all the Europeans, Native Americans, Aboriginal Australians come from.
Exactly. So
it's very counterintuitive for many people, right?
You know,
a lot of people think a lot of Africans are kind of alike.
Exactly. Right? Like they all have the darker skin, the same color of eyes, and like, so it's just like those phenotypic difference.
The superficial traits.
Exactly.
They're superficial.
They are very superficial. They can it's like just like a small differentiation that have I mean, it's not actually a huge consequence. It's like a very visual consequence. And because you see that visual traits, you think those people are very different.
Between the European and the Chinese, for example, or between Native Americans and Aboriginal Australians.
Exactly. But actually, in terms of like differentiation of our DNA, it's like a very small difference.
And what about then, what would be the two groups of humans that you can meaningfully pick and name that would be most different from each other?
We know that the most divergent group of like African are between like the Khoisan, so those hunter-gatherers, but you also like...
in the Kalahari Desert, right?
Exactly. But you also have like the hunter-gatherer, like pygmy from like Western Africa, like the Mbuti.
And so they're in the rainforest.
They are in the rainforest. Yeah. So like, for what we know is like the most differentiation is between those like the hunter-gatherer Mbuti and the Papuans from
the Papua New Guineans.
Exactly.
And this is very counterintuitive for many people because what you said earlier, the superficial similarities, you show a photo of the Papua New Guineans and the Mbuti, many people... pretty similar.
They're pretty similar. They're like relatively like, you see more similarity in the trait that you can observe between an African and a Papuan than you see between an African and a European. But that doesn't reflect the diversity of the genetics of those individuals. That sometimes results in also a lot of traits actually that we don't see that can be susceptibility to disease and things like that, not visible, but there's a lot of also difference there.
So if we were to imagine a two-dimensional, on a piece of paper, drawn human family tree, modern human, Homo sapiens family tree, you would find African hunter-gatherers on the one extreme, and on the other extreme, again, darker pigmentation, skin in Papua New Guinean, Aboriginal people. And in between, you have Native Americans, Europeans, Arabians, everyone.
Yeah. What you have to understand is darker skin was like the skin of everybody. At least like now we start to have evidence that lighter skin only emerged less than 10,000 years ago. So it's very, in terms of like the scale of evolution, is very, very short.
Yeah, the famous Iceman, the Ötzi, the new reconstructions are wonderful because it's probably this guy walking on the Alps had skin that we would associate with Papuans or Africans nowadays.
Exactly. Like 10,000 years ago, everybody that lives, like probably most of the people that lived in Europe had darker skin.
And they evolved lighter skin, am I right? Because you get better vitamin D from a lighter skin. And when farming spreads, you get less vitamin D from the good old fish and mammoth meat or whatever. And therefore, it's a good idea to start evolving more lighter skin.
Exactly. So actually, we used to think that people evolve lighter skin just like with the out of Africa. When the sun exposure reduced and you synthesize the vitamin D, getting like the stimulus from the sun exposure. So when you have less sun, you have less vitamin D. And if you have a darker skin, even less vitamin D, obviously. So lighter skin allow you to absorb more sunlight and get more vitamin D. And then it's only like with the genetics that we discover that no, the light skin actually appeared like very late on, not just like when the human went out of Africa, because like during that time, they will find enough vitamin D in the diets, right? And when there's like the switch into the diet, this is where you have the strong selective pressure into finding a way to synthesize more vitamin D. And this is how the light skin got selected.
And now let's go back to that image of a human family tree. We have these different branches. On the one extreme, for example, the Mbuti hunter-gatherers in the Central African rainforest. On the other extreme, the native Papua New Guineans. How different are they from each other? Is there any meaningful way in which we can measure that or visualize that or compare that to some other groups?
When you compare to like other form of human, they are still relatively close. So something that is like very interesting when we compare those differentiation between modern human to like other form of human, we realized like those other form of human, like the Neanderthals, were much more the different population of Neanderthal, even though living all in Europe, were much more differentiated between different population of Neanderthal than like any modern human population.
Well, wait, let me get this right. So first of all, the people alive today who are genetically most different from each other are African hunter-gatherers on the one hand and Papua New Guineans natives on the other hand.
Yeah.
And Europeans, Chinese, everyone's in the middle.
Yeah.
And even with this spread, it is a smaller spread than when you compare Neanderthals in Western Europe and Eastern Europe.
Exactly.
Wow.
Yeah. So, yeah.
Wow.
And it's very surprising for
It's
everybody
very surprising.
because we used to think of a Neanderthal as like one group and one population.
Almost like another, a bit more different than the Chinese and the Europeans.
Exactly.
But no.
But no. So the difference between different Neanderthal population, even not living so far away from each other, or even not like having diverged for as much time as modern human population, they will like undergo so much selective pressure and like probably also cultural pressure that the differentiation between different population of Neanderthal is higher than that what we see between the most divergent modern human population today.
My final question always to guests is, how has all your research shaped your outlook on humanity?
Definitely we are one. I think this is like what I'm realizing now. And like it's even between like, despite like those like differentiate between different population, we kind of like always find a way. Like, for example, I was talking about modern human. And when you think about, African hunter-gatherer, and like we're saying like, and like even like African people and European, you have the feeling that they are so divergent, right? Like, but like, and then you realize that like when you look at the DNA, they're like relatively close. We that common history. First of all, we have a common history. We diverge from a common ancestor. But even despite that, we like kept on meeting and mixing over the year. And like what I've just realized is like when I'm like studying human evolution, I'm now realizing that you don't have any evolution if you don't have any mixing. It looks like there's no evolution that just like one population, like just like evolve in a linear way into a better form. It looks like with everything that we see now is like you have one population in a place, stay quite constant in their way of life until another population come and mix with them. And that mixity create new technology, new way of seeing life, new kind of human being with new phenotype. And this is what evolution means. So it's not just like you are at a point A and then through time you evolve into B. No, you evolve into B because in between A, you met like A1 population that come and mix with you. And in another time, A prime population come and mix with you. And then you reach a point B. So it's like just that idea of like mixity that come all together and that can build like the driver of evolution, which is something I just was not aware when I started studying human evolution like 15 years ago.
Diyendo Massilani, thank you so much.
You're welcome. Thank you for having me. It was a pleasure.
Okay, so that was it for today. Thanks for sticking with us until the very end. And stay tuned for this Thursday's final episode in this short trilogy on the intersection of archaeology and genetics. The next one will be about more recent times, about the way that humanity has spread around the world, focusing especially in the two places that in the traditional way of telling a story have been the two further edges, Polynesia in the east and the Americas in the west. But as you might guess, that's not the end of the story, so stay tuned. Until then, take care.